Hello, Math 2412 pre-calculus students. Here's part 3 of the basics of trig you need for calculus. So in the last one, we talked about how to come up with the sides of 30, 60, 90 or 45, 45, 90 triangle when the hypotenuse is 1. Here's why we were doing that. Put this information together with what you saw in the first video. How we are going to define the cosine and sine of an angle all depends on what that angle looks like when it's in standard position, okay, and where that terminal ray, p sub theta, which is where the terminal ray, intercepts the unit circle, what the coordinates of p sub theta are. So as you saw in the first video, if the angle theta is equal to 0, the initial ray and the terminal ray are coincident, and the point p sub theta there in blue, if you can see that, there's p sub 0, right there, it's at the point 1, 0. And so for that quadrantal angle, it was easiest. Oh yeah, those are the coordinates 1, 0, and therefore, with our definition of cosine and sine, let me remake this here a little bit, give a little more room. Right, so if p sub theta is 1, 0, then the cosine of the angle is just that first coordinate, that x coordinate. And the sine is just the second coordinate, the y coordinate, right? So back to that definition of cosine and sine, right? Now, for pi over 6, which is the same thing as 30 degrees, right? If we put theta in standard position, 30 degrees, p sub theta is intercepting the unit circle right there. So let me, that determines, now if I drop the point P, if I drop a perpendicular from there down to the x-axis, I'm going to call that a point Q. So this was p sub pi over 6, there's q sub pi over 6, there's 0, O, which is taking the role of the origin. Let me enlarge that picture here so I can see the lengths of the sides. The angle theta in question was pi over 6, or 30 degrees. So that angle right there is 30 degrees. If this, since p sub theta is where the terminal ray intercepts the unit circle, that means O to P, the distance from O to P, is always equal to 1. Right? Drop that perpendicular down to Q. Now we have a right triangle. 30 degrees there, force is 60 degrees up there. That's a third OPQ here, the triangle OPQ is a right triangle, and it's a 30, 60, 90. So if that hypotenuse is 1, that short leg is a half, this long leg is square root of 3 over 2. Now overlay that with the fact that this triangle is that one right inside that version of the unit circle in the coordinate plane. So the coordinates of the point P have to be positive square root of 3 over 2 and a positive 1/2. And therefore, for example, the sine of pi over 6 is what? The cosine is what? You should also be able to answer those questions if they're not in order, right? So the sine of pi over 6 is a half. The cosine of pi over 6 is square root of 3 over 2. What I'm showing you is what you can deploy for any angle. Now, since any of the special angles, multiples of pi over 6, or pi over 4, or 0, or pi over 2, you should be able to draw the angle in standard position, find the resulting p sub theta, and drop down to the x-axis to get q, or project up to the x-axis to get q. Q is always on the x-axis. Find that triangle, find its put on its links that you know so well for these special angles, you know them all, and pull off the coordinates of that point P, remembering, always asking yourself as you go from here to here, what quadrant is this in? What quadrant did P sub theta land in? In the first quadrant, the links of the sides are equal exactly to the x and y coordinates. Not so in other quadrants. For example, let's see, so if we get past pi over 2, so you notice my angle is increasing as I'm going along here. Here, notice that the angle is growing from the initial ray to the terminal ray. Keep that in mind. What's the first special angle past pi over 2? 2 pi over 3. Okay, so we draw 2 pi over 3. Again, I'm assuming you know these angles in radians, you know which quadrants they're landing in. We're just reviewing the trigonometry. So 2 pi over 3 gives us the fact that P sub 2 pi over 3, this point here, is in quadrant 2. In quadrant 2, don't forget, every point has a negative x coordinate and a positive y coordinate. You don't have to memorize, or you have memorized that from your algebra days, right? So you don't need to write it down anymore. That should be pretty obvious. But in quadrant 2, negative x coordinate, positive y coordinate. You can overlay that fact with the fact that if you drop P sub 2 pi over 3 down to Q sub 2 pi over 3, you get this right triangle here. That's a square root 3 over 2 on that longer leg, all right? And 1/2 down here and 1 there. You put these two pieces of information together to say, oh, the coordinates of this point, P sub 2 pi over 3, is that the x coordinate has to be a negative 1/2. The y coordinate has to be positive. So trying to memorize a whole bunch of rules about when the cosine and sine are positive or negative and so on and so forth is a fool's errand and is not what you want to be wasting your time doing when you go into the calculus. You've got to be able to find the cosine and sine of any standard angle or its multiples like that. This is how it's done. Draw it in standard position, get the right reference triangle, remember what quadrant you're in, and there you go. You've got those coordinates, and therefore if you're using your definition of the cosine as always the x of an angle, theta is always the x coordinate of P sub theta, then that's your answer for the cosine. There's your sine of 2 pi over 3. It's square root of 3 over 2. Okay. You should stop the video, work out these other two. 3 pi over 4, 5 pi over 6. Come back and check to see if you have these points down here. Come back, stop the video and come back. Come back, now you've come back. The sine of 3 pi over 4 is clearly a square root of 3 over 2. Oh, excuse me, square root of 2 over 2, my bad. The cosine of 5 pi over 6 is a negative square root of 3 over 2. What's the sine of 5 pi over 6? That's that 1/2. That's 1/2. What's the cosine of 3 pi over 4? It has to be a negative square root of 2 over 2, just because 3 pi over 4 terminates in quadrant 2. All right. Now, of course, you should continue this process. You do all this as you go into, as you increase the angle theta beyond the second quadrant. What happens when theta terminates in here? Can you find all the special angles? Find their terminating point, P sub theta, in there, and therefore find the cosine and sine of those angles. And in quadrant 4, you'll be tested in that I'll just be asking you, and you will not be using a calculator, how to find the sine or cosine of any of the special 17 angles from 0 to 2 pi using this method. That's what you want to be able to do. All right. Next video, we'll continue with more trig functions, where they come from, and what identities are true about them.